Alright, let's start off by reviewing normal PA line tracings. We've already talked about normal PA pressures, and they typically range from 5 to 25. And we start off with essentially a CVP tracing, which I'm going to deliberately exaggerate here for the purposes of discussion, and then progress to a RV tracing, and then a PA tracing, which is identified by a step up in the diastolic pressures when compared to the RV, and then ultimately a wedge tracing. And so we have RA, RV, PA, pulmonary capillary wedge pressure. And for the purposes of this discussion, it's always helpful to anchor yourself with the ECG. And the ECG, the P wave represents atrial contraction, and the T wave represents, and that's a pretty poor ECG, but you get the idea. And so we know that the A wave, which we'll talk in detail shortly, represents atrial contraction and therefore follows the P wave. And the T wave represents, the V wave represents atrial filling and often follows the T wave. And so when you're looking at a tracing and are really not sure which wave is which, you could start off by looking at the ECG and knowing that immediately following the T wave is often the V wave. Immediately following the P wave, if one is present, is the A wave. And we'll define the different features of this tracing. So then we often have a C wave illustrated here, which we'll talk about in detail, and it may not be present in every tracing. This here represents the X descent, and this represents the Y descent. And now, although we focus on the RA tracing or the CVP tracing, as in discussing this tracing in detail, the reality is the pulmonary capillary wedge tracing is identical to the CVP tracing in terms of waveforms. It's only reflecting the left-sided filling rather than the right-sided filling. So let's define the different waveforms. We've already talked about how the A wave represents atrial contraction. C wave, which may or may not be present, reflects the tricuspid valve closing and bowing into the atrium at the beginning of ventricular systole. And the V wave represents atrial filling. Next we'll talk about the descents. The X descent has two features to it. The first is atrial relaxation. And the second is created by the downward movement of the ventricle, creating more space for the atrium and therefore a lower pressure. And the Y descent represents passive ventricular filling. So let me go through that again. We start off with the A wave, which goes right after the P wave. It represents atrial contraction. There's a short delay representing the electric mechanical delay. Thereafter you have the beginning of the X descent, which is created as a consequence of atrial relaxation. You then have a C wave, which may or may not be present, that represents the onset of ventricular systole and the closure of the tricuspid valve bowing into the right atrium. You then have an X prime descent, which represents the downward movement of the right ventricle, followed by passive atrial filling, creating the V wave, and then opening of the tricuspid valve and passive ventricular filling following the T wave. Another way of looking at this tracing is to note that the C wave represents the onset of systole that continues to the peak of the V wave. And then from the peak of the V wave until the next C wave is diastole. And again, we're focusing here on the RA tracing, which is a reflection of right-sided pressures. The same principles hold true on the pulmonary capillary wedge pressure tracing. The last point I'll make for normal tracing is that occasionally we may encounter significant respirophasic variation in a patient's wedge pressure tracing. The gold standard is to assess the pressure at end exhalation. Therefore, in a patient who is not intubated, end exhalation is often the highest pressure. And therefore, the peak of the respirophasic swings should be used. That's because the valley is created by the negative intrathoracic pressure that's generated. Conversely, in an intubated patient in which positive pressure is delivered, end exhalation is represented by the valley. So in the ventilated patient, and the easiest way to remember is that in a vented patient, you look at the valley to determine the actual pressure measurement. So that is all I have to say about normal tracings. We'll next move on to pathologic tracings.